So that's kind of the approach, and then the system considerations will be a little bit more on operations again. Somewhat prescriptive. So pedestrians at roundabouts. This photo is from a British roundabout, and it's Australian, so it's opposite drive. Actually, I think the photo was flipped. If it isn't, we have a pedestrian yield sign. That's what threw me off. So what's shown around here is a white edge line, and there's a pedestrian walking in front of the railing. So there probably shouldn't be a railing in this space here, but the point of this slide is just to indicate that, you know, roundabouts and pedestrians, we have to guide them to the right place to cross and make it safe to cross and provide good visibility. So sometimes the handrails, and they're quite popular in England and in London area where roundabouts are popular with a lot of pedestrian traffic, they tend to have to gate them and guide the pedestrian to the safe crossing locations. In North America, we're accustomed to installing roundabouts, and where there's a reasonable chance of pedestrian activity, we locate the roundabout crosswalk approximately one vehicle back, or roughly 20 to 25 feet behind the give-way line or the yield line. And it's usually the physical bullnose of the median is the point where we measure back from where the vehicle would line up. And so it allows for one vehicle queue space between the give-way point and the crosswalk. And the purpose of setting back the crosswalk is really to separate the driving tasks. A driver approaching and entering a roundabout is focused on the vehicle approaching from the left, and they don't want to have to contend with a pedestrian on the right-hand side. So there's a mix of tasks where they're really focused on one. We want to separate those tasks and have the pedestrian cross at least one vehicle back. In some instances, the exits will place the crosswalk sometimes two vehicles back because we don't want traffic to queue into the roundabout. But on entries, we tend not to push it too far back. Otherwise, we make distances walking around roundabouts too long and circuitous. And then pedestrians, you know, will ignore those crossing accommodations and cross where they please, shortest path. And that's particularly important in roundabouts, or with roundabouts in frost climates or cold climates, if we want to minimize the walking distances. The splitter island should be wide enough to provide for a refuge, and in the roundabout guides, it's generally the length of a bicycle, roughly 6 to 8 feet. You can imagine a bicycle with a trailer or a child's stroller attachment to the rear of the bicycle that you could need upwards of 10 feet of crossing area as a refuge. The reason they're angled is for visually impaired, to provide a perpendicular crossing of the traveled way, which happens to be the shortest distance, and to also impact or impede the use of crosswalks by cyclists where they simply don't yield and drive straight through the crosswalk. We try to interrupt their pathway, and so it serves two purposes. We interrupt the pathway, but we also provide the shortest distance to cross. Excuse me, for the pedestrian and for the cyclist. This is a straight-through crosswalk, and this is over in Clearwater Beach, Florida, where there's very heavy pedestrian traffic going between the beach area and the hotel district in that part of Clearwater Beach. The Gulf Coast is just on this side, Tampa Bay, St. Petersburg. The roundabout where this crosswalk is located has, I think, 7 legs. It's a complicated layout, and they get roughly 3,000 pedestrians per day. So they've had to install pedestrian crossing signals in order to meter the pedestrian traffic. You would think that you want to provide, you know, ample gaps for pedestrians, but because the pedestrian volumes are so high, it impacts on the roadway capacity because they just cross indiscriminately. So they've had to control the pedestrian flow using signals. That's a common concern in London, England, and places where there are roundabouts with very high pedestrian volumes, is to use the crossing signals as a metering device. This one again has the straight through, so the cyclist can simply blast through the crosswalk, and that's something we don't want them to do. Even though they may have think they have the right of way, the driver still has to yield the right of way. So you can see pathways will develop where the pedestrian isn't accommodated in this leg of the roundabout in Clearwater Beach. This is when it still had the fountain that was taken out later, had a wall along the edge of the central island. But this was a heavy volume crossing, and the pedestrians crossing accommodation is displaced farther from the roundabout, and there's actually now an underpass even a distance farther from where the signal crossing is. So and that connects up with bike trails. So it's good to put in discouraging plantings or fencing or something that prevents the pedestrians from crossing indiscriminately and creating problems for other motorists and safety for pedestrians. Some of the crosswalk warning devices used or prescribed in the METCD, and there's a couple that I quite like and have been used successfully in places like Columbus, Ohio, where they place the state law pedestrian crosswalk in between the two lanes of entering traffic. So it's actually, on the marking, on the lane line, they place this sign. And the Director of Public Works argued that, better to have a slow, safe pedestrian crossing and not worry about having to replace the sign every 3 to 6 months because it gets knocked down. It's a knockdown sign to begin with, but in the wintertime it's difficult to keep it in place with snow plows and truck traffic, as you can imagine. It's not uncommon to see this yield here to pedestrian regulatory sign on the crosswalk approach, or right next to the pedestrian warning sign. The problem with some of these signs is they can block the vision. They can block your vision of the yield sign. They can block the view of the yield sign downstream of the pedestrian crosswalk sign. So I rather like the state law sign. Unfortunately, METCD does not prescribe the use of this in the roadway. If it's to be anywhere, I believe it's roadside only. So they're not to be placed on splitter islands, and they're not to be mounted on signs above the ground. So there's a number of restrictions to using it, but I think there are a number of agencies that would like to put in a request to experiment and try to make better use of those signs. The types of crosswalk markings that we see that in the first photo that I showed you of a roundabout, there's this ladder style with transverse lines as well as the longitudinal rural lines, or the zebra crossing as it's sometimes referred to, which is this design over here. I think in Canada they use the zebra crossing in rural designs, and they use the standard transverse bars or parallel in urban considerations. I think an agency should choose one or the other and not really mix and match. The point being, you want to convey a strict message to the driver that if the parallel lines mean one thing, does the zebra crossing mean something else? So the intensity of the markings, shouldn't be a differentiator. We want drivers to stop for pedestrians at any crosswalk. So it's a matter of choice. Now, the idea of not providing any crosswalk accommodation, I wouldn't oppose that. In Europe, and particularly in England, they have a sort of a needs test, which is a function of the pedestrian volume times multiplied by the vehicular volume squared, so raised to the power of 2. And that volume is pedestrian PV squared, as they call it. They tabulated certain thresholds where no crosswalk is required, where a crosswalk without markings is required, and then moving up to a full signalized crosswalk is required. The idea being, you don't want to present drivers or pedestrians with a false expectation of either the right-of-way or protection in the crossing of any kind. So where there's almost no pedestrians, does it make sense to paint a crosswalk? Now in North America, we're inclined to either provide the ladder or the zebra, and some still do the parallel. And we provide it whether or not we have pedestrians crossing at our intersection. And so we really don't differentiate between low and high volume pedestrian crossings. And that may be attracting some concern, particularly when the pedestrian thinks they have the right-of-way, and drivers aren't accustomed to giving it because pedestrians are infrequent. That's when we set up pedestrians for a false expectation. I'll say a bit more about that in a minute when we talk about comparing signals to roundabouts. In the roundabout guide, Federal Highways Roundabout Guide, NCHRP 672, these diagrams are provided just to show the desirability of additional separation from the back to sidewalk. U.S. Access Board requires a strip of contrasting treatment, either tactile or visual, to separate the sidewalk from the traveled way, and not just the back of curb and grass. It should be something tactile, and so that the visually impaired pedestrian doesn't venture out into areas and cross where it's unsafe to do so. And this sort of enclave-looking area could be planted, could be landscaped, it could be a combination of contrasting brick pavers and some landscaping treatment, as long as the height of it doesn't restrict sight to the left from drivers entering downstream. So this is a common dilemma when we're dealing with pedestrians. The discussion of pedestrians in a public meeting setting, it's quite common for motorists and pedestrians who attend these public meetings on roundabouts to argue that there's no walk signal, there's no accommodation of the pedestrian. And the thing we try to point out to them is to give them the accurate sense of safety associated with signals. And if you enumerate all the driving tasks associated with a signal and compare it to a roundabout, a signal is in many ways more complex. But because it's, we have habits of understanding signals and we know how to drive them, and pedestrians know how to cross them, we tend to have a sense of security associated with traffic signals. But what we find is it's an exaggerated level of security. And in fact, the safety performance of traffic signals is below or reduced as compared to roundabouts. Roundabouts tend to provide better safety for pedestrians, but it doesn't feel that way. And so people come out to public meetings and object to the use of roundabouts. So if we look at the different movements that pedestrians would make in vehicles, you see that there's issues with the driving task of the driver looking for a left-turning vehicle, an opposing vehicle coming through, and their last consideration is the pedestrian in the crosswalk. And many of you would know that there's people that are at risk in crosswalks and may have a relative or a friend or an acquaintance that may have been struck in the crosswalk when they had the walk signal, making it appear that it was safe to cross when it wasn't. And the right turn on red is a common problem. This driver, looking to the left and seeking a gap to the left, and then turning right without looking to see if there's a pedestrian in the crosswalk. And of course, the visual from the pedestrian back to the vehicle, by the time he's 2 or 3 feet into the crosswalk, he doesn't even see the vehicle coming at him from behind. So we tend to feel secure in traffic signals, but in fact we're not. And statistics show us that. So the feeling of security in roundabouts more closely matches their actual level of safety. So the visibility between users and the speed in the area of conflict are all more conducive to pedestrian safety. Lower speeds near the crosswalk, ideal visibility, pedestrian only has to look in one direction to cross, and the crossing distances are shorter. So inherently the roundabout crosswalk should be better, but because we don't feel as safe there, we're going to tend to behave more assertively. And so we often point and walk, or we look and people will raise their hand, or you've seen the red flags at some crosswalks. We try to associate roundabouts with a new way of crossing or assertive behavior, and we encourage agencies to teach pedestrians to point their finger in the direction of the crosswalk and look to the driver and try and get their attention that way. We're not trying to stop the driver or hold the hand up to stop them. We're simply pointing our attention to cross and waiting for the driver to respond. And it's surprising, drivers are not that responsive at times. So we've prepared some educational videos that highlight that. If we have a bit of time at the end, I'll grab one and pull it up, and you can see how we educate pedestrians in crosswalk. So designing for pedestrian safety, we want to make sure entering vehicle speeds are low, and that's complicated and challenging to do in situations where you have 3-lane entries and it's difficult to get speed control. So pedestrian safety in the exit crosswalk is going to be a function of the speed of traffic in the crosswalk area. And if we can't slow the driver down on the entry, we're going to have problems with pedestrian comfort in the crosswalk areas on downstream. We want to provide the refuge area, as I mentioned, bicycles, wheelchairs, to permit that two-stage crossing. A clearly defined splitter island with ramps on ends and detectable warning surfaces to meet U.S. Access Board requirements. We want to discourage pedestrians from crossing to the central island. And so the central island should never be landscaped or decorated in such a way to encourage pedestrians to want to cross to the central island. So we locate things like signs and landscaping so that pedestrians and cyclists are not hidden, and that governs the height of plantings and the placement of signs. And of course, we make sure that our street lighting provides a positive contrast. We don't have a lighting module in this series, but I'll say this much for roundabout lighting, and that's that it's not about completely flooding and illuminating the roundabout. It's about target lighting, and that's, we get that from our European cousins who have done roundabouts and other types of intersection design. They're minimalists in many ways, a very efficient approach to lighting design. And positive contrast is where the light is actually in front of the pedestrian crossing, so as the vehicle approaches, the pedestrian is vertically illuminated, and they're much more visible to the driver approaching. Now, if the light was behind the pedestrian, it would be negative contrast, and all you would see is a dark silhouette, and the light would be flooding in front of them. So we're very deliberate about placement of light poles relative to crosswalks. Pedestrians with vision loss at roundabouts, probably a lightning rod issue with roundabouts, and certainly there have been a lot of discussions. There have even been lawsuits. In Michigan, there was a lawsuit by a lawyer, an attorney who was blind. He went after Oakland County for a 2- and 3-lane roundabout that he might never cross at, but he felt it wasn't accessible, and took them to court. And I'll show you actually a photo of that roundabout and what was installed as a retrofit. The thing about pedestrians with vision loss or partial vision is that it's difficult to find roundabouts, and it's difficult to navigate them if they aren't given good guidance on where to cross and the comfort of where to cross, and having distances shortened in locations where they have to cross. It's also difficult for them to create gaps in traffic. I talked about point and walk. Most blind or visually impaired pedestrians that carry a cane are told not to raise the cane to point their intention. Now, in some of the pedestrian studies where blind pedestrians were used as subjects, when they did raise the cane, the vehicle stopped instantly. But when their cane was at the ground and they were standing at the roadside, they were often overlooked by drivers, which is a bit of a frustration. So we have to consider possibly extra treatments for blind pedestrians. Single-lane roundabouts are said to be an accessible intersection from the U.S. Access Board. At least that was the original language in it, in some of the guidelines published on accessibility. I'm not sure that I can agree with that. Anytime you have a pedestrian that's crossing a roadway, there's the chance that vehicles won't stop, and even if the crossing is short, as it would be for single-lane roundabouts, I would still be concerned about the accommodation factor. I'm one of these people that subscribes to the Boy Scout rule, and yet that doesn't represent personal freedoms that some of these regulations and provisions in legislation protect and provide for. The free movement of anyone around an intersection. But that's a challenging thing to provide for agencies and for engineers to design for that level of accessibility. As we noted with the traffic signal control, just because they have a walk signal doesn't mean they can get across safely. So sometimes additional support or accommodation is necessary. So we can debate that for a while. As it stands, the U.S. Access Board has published some draft proposal for access of right-of-way, which is a fancy way of saying rules for crosswalk design and treatments. And at present, they have the need for traffic signals. MUTCD and some of the committees, whether it's roundabouts or traffic signals, are responding with development of new devices for audible, countdown, and pedestrian actuation. In the roundabout side of things, they're doing research on a rapid rectangular flashing beacon. I'll show you some examples of that. I think again it's about positive guidance, getting the pedestrian to the point of crossing comfortably and safely with well-directed pathways that have contrasting treatments on their edges. The photo in the top right corner is a British roundabout, and so you can see the use of gateways to keep them out of the tulips or to keep them from crossing where they shouldn't. The raised pedestrian crossing has been researched along with devices like the hybrid activated walk signal and the rapid rectangular flashing beacon, and surprisingly the rates of yielding and compliance and the responsiveness of drivers was quite high with raised crosswalks. In fact, the point at which drivers yield on average was, I think, in the 6 to 8 second range compared to other devices. It was quite good, even signals or rapid rectangular flashing beacon. Crosswalk ranked very high, rather surprising. Designs like this, you can see there's not a great visual here, even with the contrasting pavement and some of the markings here. It's at any speed, it would be difficult to tell that this is actually a raised crosswalk, and it's going to deflect the vehicle if they don't slow down. But it kind of begs the question, if you've designed a roundabout properly and you have good speed control at the roundabout, do you really need a raised crosswalk? And that was my initial reaction to the use of these. And these were actually placed on a roundabout in Avon, Colorado, one of the first roundabout corridors in North America. And it was a retrofit. As you can see, the drainage goes through, so the crosswalk has slopes on the ends as well. And that's probably also helps with ADA and accessibility factors. But this roundabout had reasonable speed control, and it was a retrofit in response to complaints that pedestrians brought to the town of Avon. Avon has been recording collision statistics on these roundabouts since 1997, and there have only been 1 or 2 exchanges with vehicles and pedestrians involving slight injury. It's the record and the reports are very good on the pedestrian safety. Still, other countries, in this case Sweden and even over in New Zealand, they're using speed platforms, and as compared to a raised crosswalk, the speed platform has a raised bump on the approach side and then a gentle departure slope. And the idea being that the vehicle only gets 1 bump or 1 bounce. They call it the single bounce roundabout. With the research that's been done by some of the Department for Transport in Sweden and also in New Zealand, they found that the 3 to 4 inch or 75 to 100 millimeter was suggested. In Sweden, they use the 100 millimeter platform and 1 in 13 ramp. It avoids the double bounce challenge with heavy trucks and buses and that sort of thing. One study in Auckland demonstrated about 85% vehicle speeds in the range of 25 to 30 kilometers per hour, which is quite low. That's 15 to 22 miles per hour. That's a very reasonable speed in the vicinity of a crosswalk. And that was with a selection of 6 speed tables on roundabouts, or 6 locations with 4-inch speed tables. And they had 1 in 10 gradients on the approach and 1 in 15, or 1 in 10 to 1 in 15 on the approach, and gentle or flat, nearly flat departures. It's not a desirable speed control form in the first instance. In other words, to install it with a newly opened roundabout. It really should be as a retrofit. And on arterial road systems, it's difficult to justify or argue for the placement of speed bumps or speed tables on arterials, given the high percentage of large vehicles, including buses and fire trucks and so on. So it should be part of a safety strategy to improve bicycle and pedestrian safety as a retrofit. Okay. Crosswalks displaced farther from a roundabout. This isn't intended to show 2 crosswalks in the same approach, simply that there's the option of placing it near the entry point or displacing it and using a crossing system. And this is very typical in British or European roundabouts, where they separate the driving tasks of the crosswalk regulation with the yield at entry regulation. And we're not as adept at that yet. Our experience has to grow before we realize either that's a good idea or that it's a problem, as the Europeans found it to be. This site is over in Lincoln, Nebraska. It's actually had a bit of retrofit treatment because of some of the vehicular crash problems with 3-lane entries and a lack of education to the community. But the point of the slide is to show that it has 2 underpass crossings, a middle school in this quadrant, and then 2 split crosswalk hybrid activated walk signals, one on this leg and one displaced on this leg. So it's a fully accessible intersection by U.S. Access Board standards if it has countdown, push button countdown, audible pedestrian crossing accommodation and treatments. And this would be a stepwise crossing in the sense that you push the button to get to the refuge and then you push the button again to cross the second leg. So the signal phasing timing wouldn't give you the complete crossing all in one cycle. You would have to push buttons twice. And I think that's as it should be because there's a bit of a refuge. The pedestrian can wait and push the button for the other direction. Or in some cases, if there's gaps, the pedestrian doesn't need to push the button in the first place. So they'll cross comfortably without pushing the button. The pedestrian tunnel, it just so happened that the grades were conducive to this, that the parking lot grade sets up reasonably well for sight through the tunnel. Most folks know that putting a pedestrian crossing below grade and down a steep slope or inside an embankment, that there's issues with safety and security of the pedestrian. And so these ones set up very nicely. They're almost at the level of the playing fields. And so that someone walking up towards the crossing can see completely through it. And people in the tunnel can see people outside the tunnel. So they don't have to put in security cameras or anything like that, particularly with this age of user at the middle school age. The RRFB is gaining popularity. Federal Highways is undertaking tests in several sites across the U.S. and finding that the driver response and compliance rates are increasing or show promise and favorability for the use of the device. Whether or not the Access Board will interpret it as an accessible crossing without the use of red, in other words, just having flashing yellow, might not be adequate in that case. Before I move ahead, so the tests are still underway, but I think Federal Highways is pushing for this because it's a low-cost device, and if it can be found to be successful in driver compliance, then it may be considered an acceptable alternative to a full set of traffic signals, or in this case, the hawk signal. This was the one that was retrofitted in Farmington, Michigan. Oakland County was the county that had the lawsuit. In the courts, they decided that they should install these as a pilot installation and study them, and then report back to the courts on their use and success or lack of. What they found in the before and after study is that there were too few pedestrians to really form any statistics or any conclusions of their benefit. So even though this represents an accessible crossing for a 2-lane roundabout, there was really no evidence that it either improved safety or was desirable. In the end, the agency decided to leave these in, and now they put in underground on most of the 2-lane roundabouts in the event that they get a request to install. They have the hand wells and ducts underneath the pavement, the conduits underneath the pavement, so they can place them if they are warranted or if a request is made and an engineering study proves them to be necessary. The difficulty I have with this device is twofold. One, its placement in proximity to the entry and exit of the roundabout, and the challenge to the driver of having to process information from many different sources, and the confusion or the potential for error with the driver paying attention to one device and ignoring the other, or missing the pedestrian. And then the second thing is the device itself is unfamiliar to drivers. So if we really want trouble with roundabouts, this is exactly what we should be doing. Adding new devices to them, to an already challenging device, and then putting it so close to the roundabout that drivers are going to be challenged with having to process a lot of information. So the guidelines, I think, will eventually settle on something that's has this type of device or something like it, but it's displaced farther from the roundabout entry. In Canada, where they actually allow for the green indication on, and they call it a half signal, they'll put them a little farther back from the entry than this. But drivers have been known to receive the green and then fly through the roundabout without stopping, thinking that that's also the indication that they don't have to yield. So the displacement is a big factor in their design and how they're located. And this is out of the METCD, and it shows the indications. They rest in dark, and in Texas they have to pass legislation that would allow the use of a signal that goes black or dark. Then they come up with flashing yellow, steady red for the crossing time period when it's walk, and then up comes the flashing don't walk for the pedestrian, and that's the clearance interval, and we see sort of a wig-wag style, and then it goes back to resting in dark. And these would be split on the crosswalk, where you would push the button a second time in the refuge area. So report 674 is sort of the pedestrian watershed report on crossing accommodations where they're testing different devices and treatments. They looked at speed as a factor in yielding and compliance, and the willingness of drivers seem to increase. They're doing more research now. At the time I wrote this, the raised crosswalk has some promise, and the pedestrian hybrid beacon and the RRFB as well. Moving to cyclists and roundabouts, but maybe I'll stop for a minute, Nathan, give myself a breather and a chance for questions, because this was we move into cyclist pedestrian or away from pedestrian discussion, and I'd like to take any questions on that now.
Sure. So any of the attendees who have mic capabilities, I'll just unmute everyone, and hopefully there isn't too much feedback. If you don't have mic capabilities, feel free to just type your questions into the question box, and I'll JV those.
Yeah. So I mean,
Have you ever tried a European style or European design?
yeah.
Have you ever tried to mimic one of the European design of crosswalks or the roundabout?
Mark, the question is, have you tried? You were discussing some of the differences that between what is done in practice in the U.S. and what is done in practice in the U.K. Have you, or do you know of any cases in the U.S. where some of those U.K. designs have been tried? Mark, I think you're muted. Or did you get muted? Or there we go. Sorry, Mark, you were muted.
There we are. What I put on the screen, and my response to the question was, in the U.S. we can't use the device that has the standard signal indication as a half signal. It's not approved. We have to use the hybrid activated walk or rapid rectangular flashing beacon. But this is a video of a site in Canada, and I'll just play it back to the beginning here. And it's a push-button countdown with a split crosswalk, and it's placed at about 120 feet from the roundabout entry, and you can see the behavior of pedestrians. I went out and looked at this one 5 or 6 years ago. It's one of the few installations in North America that's more like the British or European crosswalk style. And the pedestrian pushed the button and then crossed without, and then they'll push the button and then they'll cross without waiting for a gap. And that's because this is not a warranted device, and they're not even bothering to push the button. So about a year after its installation, this is very common behavior on the part of pedestrians. And then if the light changes, then the drivers are stopping for the light and wondering why there are no pedestrians in the crossing. So the better technology to combine with this is what, no more show you that one, is what the British have done. And that's to install a gap out mechanism, or whether it's microwave, infrared, tactile strip. You know, when the pedestrian steps off and doesn't occupy the crossing, or at least the staging location, then the signal doesn't change, or it changes back immediately. And that way you don't set drivers up for, you know, yielding to crosswalks where there are no pedestrians. So we don't have this type of device in the U.S., and I don't think unless and until FHWA through MUTCD permits its use, we won't be seeing this. So what we have instead is this device. This is the one in Oakland County. And you can see the signal heads on both sides and overhead and in proximity to the point of entry. But it's flashing yellow. And you can see it's in its early installation, drivers are really not sure what to do. Some will pull ahead. You know, now they can't see the indication when they're right underneath it. They should be behind the stop bar. And my colleagues are crossing. We staged the video. We didn't stage the drivers, we just staged the video. And then it goes to flashing. Now flashing red means the drivers can proceed when it's safe to go, just like a flashing red indication for a set of traffic signals. And they walk. The setback on the exit is so that the stop bar can be placed. In a second the video will move over. So you see you need a few feet from the exit of the roundabout in order to place the crosswalk about 40 feet from the signal heads. Otherwise you don't have the cone of vision for a driver to be able to see the signal heads overhead. So we have to displace the exit crossing location just to accommodate the placement with those physical requirements. And the driver's got it here. It's probably in the flashing red mode, and there's a countdown pedestrian signal heads on both sides. It can be made audible, so it's fully compliant with access board. But it's, you know, it's questionable whether the device should be used. They're about $80,000 per leg, per approach to install. So that's a big expensive treatment for a location where pedestrians could comfortably cross. We'll see that video a bit later. The pedestrians can comfortably cross and find adequate gaps. This is maybe a good time to show. This is a video that was prepared by an agency. Let's see if I can get it here. And I turned the sound off, but essentially what they're doing is teaching pedestrians to point their intention to cross, become more assertive in the roundabout crosswalk. Make eye contact, and he's singing a little jingle about the roundabout dance. Much safer for pedestrians to cross assertively. You don't get the right of way till the driver gives it to you. That's actually Waterloo region in Ontario, Canada. Again, I don't do that video.
Mark, we have a question. In the Canadian pedestrian signal video, you can see one person cross and then go around the backside of the marked walk. What would be your recommendation to prevent this movement?
Well, this one, you know, it's a good example of what happens after winter. We don't have, you know, markings. The markings completely wore off. Let me just see if I understand the question. So the pedestrian is walking behind. There we are. Yeah, so a gated or plantings or something. I know where that pedestrian's going. I've stood on the building. There's a big IRS type revenue building where a lot of these employees work, and this whole crossing system was set up largely for their benefit, and they so it wasn't a warrant of the crossing accommodation. You know, we see that pedestrian shoot across behind the median. There they go. So I would place plantings or even fencing down the median on the approach to prevent that. Okay. We've covered pedestrians. We can pick up some other questions near the end again. Cyclist and bicycle accommodation in roundabouts. Maybe just a point about cycling safety. At least European studies, there's not much yet in the U.S. or Canada. The European studies show that cyclists have an increased incidence of involvement with motor vehicles in roundabouts as compared to traffic signals. So when we talk about all the benefits of roundabouts compared to signals, the capacity improvement, the safety benefits, and air quality and so on, the one that we struggle with is the cyclist at roundabouts. So it's not that the injuries are higher or more severe. We know that to be the case with signals. It's just that the incidence of involvement of bicyclists in roundabouts is higher than at signals. But certainly the injury severities would be lower. So we're very conscious of those concerns, and we'll use things like the pedestrian diversion point for the cyclist diversion point to come back into the roadway or off the roadway so they can divert to the shared path. And that option of allowing them to proceed through the roundabout or as a vehicle or become a pedestrian on the crosswalk in a shared path is pretty much standard for most roundabout designs. If there are bike lanes, they should terminate before a roundabout and force the cyclist to choose whether to become a pedestrian and divert or whether to become a vehicle and take up really the center of the lane so that they aren't passed in the roundabout. The speeds in the roundabout, especially single lane roundabouts, are low enough that cyclists can comfortably move with traffic. The question is, will drivers see them and yield to them? It's important that they stay in the center of the roadway. So we need to work with cycling advocacy groups and interest groups that promote cycling to make sure that the education on how to drive or how to cycle a roundabout is highlighted. There's a need for education, certainly. Some of the design development over the years, refining the bike lane treatment with this 8-to-1 taper, fairly narrow departure, so it's not the width of a driveway or look like an access, and some sloping, the angle about 25 to 40 degrees, and joining up with a sidewalk where it's widened out to a shared path use. So this is at least an 8-foot, preferably 10 feet shared path connecting up with an existing sidewalk. So that's the approach, and then the departure from the roundabout, sort of a redirect into the bike lane with the markings so the cyclist coming through the roundabout can divert to the bike lane. And these are common dimensions. This one was developed by Wisconsin DOT, and it's kind of a hybrid of a design by Caltrans. So they can leave the roadway and use the bicycle ramp. So we don't ever provide separated bike lanes in roundabouts. We would never paint a bicycle lane into a roundabout. We would terminate the cycling lane and show the diversion point, go to the wider sidewalk use, shared path in this case. The difficulty with this is, does the pedestrian continue, or does the cyclist continue with pedestrians as a pedestrian, or do they stay mounted on the bicycle and interfere with pedestrian activity? And there could be lawsuits that develop over this. I think that has to do with the city's ordinances, municipalities' ordinances, whether or not they allow cycling on sidewalks in their jurisdiction. And I think any agency, listening in on this should seriously consider the legal implications of mixed use of cyclists and pedestrians on shared use paths. The reentry point. There's different designs for the reentry point. This one has no angle. The other design that showed the angle. This is a comfortable reentry point where the cyclist doesn't have to make a direction adjustment. This one is a slightly different version with a little bit more body language to it. A little more difficult to snowplow or to maintain this, likely a dust catcher. And so we look at the flatter taper version as opposed to this one that's a little more abrupt. And so there's different designs that develop. This one happens to be in Madison, where a two-lane roundabout with overhead directional signs combined with regulatory, cyclist lane ends, and a good skip light showing the departure point, clear poles and things like that. All those are important considerations for the cycling community. Another design. This one's not as well developed because it's on a curve, and the reentry point on this one isn't as well developed either because the angle into traffic is quite steep. So questions about the cyclist discussion?
Mark, on the side-by-side comparison of those two bike ramp or bike lane facilities that you had, I'm looking, yeah, 35. So it looks like in the picture on the right that there's some textured pavement there, or like paving stones of some sort. Is that done with intention to maybe force the bicyclists to get off their bike and walk it while they're on the sidewalk?
Yeah, that could be. This is also refers back to the comment about U.S. Access Board's desire to have the separation between walkways and the back of curb using some tactile or differentiating, contrasting treatment. And so it's discouraging cyclists as well as pedestrians from using anything but the designated pathways. This is kind of an emerging, evolving science. If I was to just take a moment and show you some of the treatments in England, I think this is worth looking at. Actually, maybe the better way to do that is with a video. I'm just pulling up a couple of photos of, to show some of the contrasting treatments and guiding treatments they use in England in British roundabouts. See if I can find a couple of photos here. There. So this happens to be a mini with 2-lane entries and 3-lane entries, but they use a kind of a cobbly, concrete with some pebbles that makes it very, very difficult to walk or discouraging to walk across. There's other treatments by May, some of the cobblestone treatments. I want to show you a higher capacity roundabout, if we can get to that. In that group. Bear with me here. Preview these videos before we. There we go. This is what I was looking for. So they're quite adept at this in Europe. It's almost archaic in the look of it. It looks like the mail of a jacket of armor from something medieval. But it has that effect of discouraging vehicular traffic on the outsides. It's also on the edge of they don't use truck aprons on most roundabouts in Europe or in England. So this is going to discourage trucks from overtracking. It's going to discourage pedestrians from walking in these areas where they're restricted. Actually, this roundabout is an interchange roundabout, so there's really no pedestrian crossing accommodations whatsoever. And the whole idea is to keep them away from the roundabout to begin with. And of course, it's left-hand drive too. I think we're going to start to see this more and more, because we have truck drivers at roundabouts, show you in a few slides some of the designs, but they're getting pretty sloppy, with their use of just overtracking the curbs on the outside. And even where we provide a good accommodation of the pedestrians, or sorry, the trucks, they're quite sloppy with the. We go on trips to the UK and learn a lot about roundabouts. They have big trucks there too. The cabs aren't as big, but the trailers are big. Okay, and if there's no other questions on that module, I'll move to trucks at roundabouts. Hot topic. Standard trucks in multi-lane design. questions that arise in the designer's mind. What's the design vehicle we need to use? It's common, National Highway System WB65, but we'll often design for a 65 and check the WB67, or look at things like house moving trailers that are still permanent vehicles. In other words, they're conventional and they don't require a permit to be on the road system. It's important, though, as we talk about design trade-offs, that we have a thorough discussion of this, and between agencies and designers, whether it's consultant or in-house staff, that we document those discussion points and trade-offs, because a roundabout that's very accommodating of trucks is not necessarily going to be the safest roundabout for pedestrians. And I'll show you some designs. There may be some designers in North America who would argue that you can make them safe for both or comfortable for both, but there's going to be trade-offs. A large roundabout accommodating trucks is likely to have higher speeds. So we look at categories for context discussion, and there's been some categorization of roundabouts in regards to trucks. The use of apron and the sizes, even grading and crossfall, for the lowboy or the flatbed truck that comes through a roundabout, and the effects that can have. The effect of striping the circulatory roadway is a point of discussion, something we didn't used to do until about 10 years ago, and now we seem to be having some difficulties with it, and not just with trucks, but with passenger cars against passenger cars. And what percent of truck traffic justifies which case or which category of design we consider? And I'll give you some examples where it's a difficult thing to judge. And then how do we educate both truck drivers and passenger car drivers to distinguish one design from another? And what visual clues are evident for either driver, truck, or car to discern what case they're driving and how to approach it and work with it. So there was a study done a few years ago between a couple of agencies, pooled some funds, and did a study of the standard trucks with the goal of establishing some guidelines for design. They categorized roundabouts in cases 1, 2, and 3 where, and these are multi-lane roundabouts, where the truck could not stay in lane entering or circulating, in other words, no lane discipline, where the truck can stay in lane entering but not circulating, which might present a contradiction, and where the design is large enough with both entering and circulating lane width and capacity for the trucks to stay in lane throughout. The study found that case 2 was the most common, and I'll show you examples of each. And at this point, that study was, I wouldn't say conclusive. It didn't collect enough crash statistics, and it didn't inventory enough designs to argue for one case or another, except to be context sensitive. I think that was one of the recommendations, was to be highly context sensitive. So single lane roundabouts, generally the ICD is sized to accommodate the largest vehicle, probably WB65, 67. And then use of a truck apron accommodates the swept turning path where you don't want to provide 2 lanes of traveled way. You keep it fairly narrow and then use apron area to the left of the truck as they circulate to provide rear wheel and trailer tracking. So most often the swept path of the truck determines the width of the circulatory roadway plus the apron width. But in multi-lane roundabouts where the truck can occupy the traveled way without overtracking curbs, when we start to stripe them, the width of lanes becomes an issue. So our choice of design vehicle and the number of lanes we have and the size of the circle, the percent of trucks, and the question of lane discipline, these are all ingredients and parameters that are interchanged and some traded off one to another to determine how big and accommodating the roundabout should be. So in the discussion of cases, this is a rural roundabout with flared entries, and so 2 lanes drop to 1 in the exits, single lane expands out to 2 in the entries, and it's a case 1. So there's no lane discipline for the largest truck. They'll enter and they'll circulate over tracking lanes. And you can see side-by-side passage of cars in 2-lane roundabouts. The case 1 design, we'll always do those design checks to make sure the truck can fit, and in most cases they'll never need the apron because they're not staying in lane entering and they're not able to stay in lane circulating. So this is probably a classic British roundabout design, except the Brits wouldn't put a truck apron on their designs. They would simply have this travel way of about 30 feet, entries of about 26 to 28 feet, and they would stripe and possibly put the dot to the left of the left turn arrow and have the truck go right up the center of the lanes. 53-foot trailer, depending on where you place the rear dollies. 43 feet, I think, gives you a WD65. I think that's probably the maximum. So to get to a 67, it's maybe it's 46 or 47 feet. There's a couple more feet to get to 67 from the 65. But there's quite a difference in swept path requirements between the two. So we often design for 65 and test or check for 67 to see if it'll work. Advantages of the Case 1 design is that it works with a wide variety of alignment methods and approach. It's the most flexible because it doesn't accommodate the truck. It can be a compact circle and it can fit in difficult constrained right-of-way environment. It generally is associated with lower costs, and of course there's less pavement marking. So this is a case where the roundabout approach could be striped, but the circle wouldn't necessarily have circulating paint. And there are some roundabouts, quite a number actually in North America. Well, it surprised some people to know that there's 20 or 30 unstriped roundabouts in existence, some of them for close to 20 years now. And they are basically all Case 1 designs. So the truck driver enters and seeing no striping in the circulating lanes, with no pavement arrows either. They just take up all the space they need, and often will prevent other drivers from getting in beside them by keeping on the right-hand side and making sure that if someone can pass them, that they can see them on the left. And we've spoken to truck driving companies about this sort of thing, and we get different responses, but generally they like to be able to take up as much of the roadway and prevent traffic from getting beside them. Another Case 1 design, we didn't stage this. This is a rural design with the trucks purposely straddling before they get to the entry. So when they enter, they have all the space required. So this is actually a slightly over-designed or oversized roundabout because with all that traveled way and no circulating lines, they really don't need the apron. So, and you can see the size of the truck. So there's very generous circulating space here. And it almost suggests that the truck can get in the car, the van in this case can get in beside them comfortably. And that's not necessarily what you want to do. So some disadvantages of the Case 1 design is it can, the trucks can introduce additional delay. That was sort of our first reaction 10 or 15 years ago as well. If we recognize the trucks can't stay in lane, is that going to impact on capacity? And you can see it might in cases like this. The trucks may continue to off-track and outside of curbs and creating damage if they can't fit within the curbs. And there may also be interaction with cars and trucks, causing crashes. The Case 2 design is something a little larger than the Case 1, and it uses a truck gore. We refer to it as a truck gore or a painted hatching area, 4 to 6, 7 feet wide on entries. And this design is single lanes in this approach, 2 lanes in this approach, and then 2 in the trunk highway direction. It's a rural high-speed approach roundabout, and that provides that over-tracking area. Some advantages is that this was indicated as a preference over Case 1 because the truck driver can at least stay in lane when they're entering, and when they head off from the yield line, they can either cross the lanes, or if there's traffic beside them, they can try and stay in lane, or if they have to use the apron for a left turn, it becomes evident. So it's a bit of a staging approach. What we're not clear on is whether or not the truck driver can see if they're approaching and there are gaps and they can enter without yielding, whether or not they can tell that there's no lane discipline circulating and see that well enough in advance. And so there's some research that needs to be done on the human factors of this design and whether it's perceived the way we intended it or whether they're interpreting it some other way. So they tend to have a little better capacity, and they work well in rural and suburban environments, and they may have greater public acceptance. We're not sure, but that's something worth looking into. I wanted just to show you a little video of some of that type of operation. So we'll see some 2-lane roundabouts, Case 1 design, very high truck volumes. WB 50 in the right-hand lane, probably a 62 or a 65. And he's trying to stay in lane, but you can see that that's not possible. So he tries to keep the traffic on his left side, and you see that's pretty common with most of the drivers. Unless they're making a left turn through movements, they'll try and come up the middle and cut the vehicle off from the right-hand side from passing them. The driver on the right is probably making a through movement. And as he heads in, there's about 9 feet of space between the next vehicle, and they pass and get away from him as quick as they can because they can see that he might be too big, and sure enough, he leaves just enough space for a car, but he still overtracks through the circle. Driver in the left lane coming up, and he sees that it's a little tight, so he's straddling right away, and he's going to take up most of the roadway. A little bit of space for another car, but you can see that that's almost inadequate to and this is typical of what the driver training people tell us, is that they'll keep to the outside if they can and keep traffic on their sight side. That's their definition of traffic, being able to see traffic from the driver's seat, looking out the window. Instead of looking in a set of mirrors, they can see it positively just by glancing out the window. Once the vehicle gets turning in the roundabout, they can't see anything on the right-hand side of the cab. The mirrors, not in the mirrors, and certainly, so there's a big blind spot. So interesting, this driver's put on his four-ways. The driver who shall remain nameless. This is no name. And again, he tracks a little bit wide then, and the traffic tends to stay away. So that's pretty common for two-lane roundabouts. So whether it's a case 1 or case 2 design, we commonly see them overtracking. And that's typical of the case 2, a 4 to 6 foot hatching area. So it creates some lane discipline approaching. And it's been found necessary to apply signs like this in British Columbia. They invented a sign with more of a diagrammatic look, showing the car and the truck pinching. This one just uses the text for now. And in time, it'll probably move to the symbol. So the case 2 designs tend to get that mix where it looks like lane discipline approaching, but it isn't lane discipline circulating. And so that's one of the disadvantages. Also, the larger circle that comes with this, the desire for speed control, because a wider entry is going to make it a little faster. Slightly higher cost in some cases. A little more pavement maintenance or pavement marking maintenance. If it's not well designed, with the space, then the truck still overtracks. So poor design can actually contribute to crashes because it presents a false message for the truck driver. And the case 3 design is lane discipline throughout both approaching, entering, and circulating. And these are larger roundabouts. The outside lanes tend to be about 18 to 20 feet, which is easily the width of 2 vehicles, 2 passenger cars. So these are large, generous, often associated with higher speeds. Though some designers are very cautious with the use of them. They try to keep the speeds down. When entries get up to about 38 feet, if the standard entry is 30 feet and they have to add 6 to 8 feet, you can imagine speeds. It's going to be difficult to control speed. Some of the surveys done of the truck drivers, and it stands to reason, if you ask them if they'd like more space, they'll tell you yes, of course they would. And I think that's not the right way to ask the question. I think it's more, if we gave you this design, how would you drive it? And in that way, because the drivers will be trained and learn how to drive roundabouts, and as we saw from those other videos, they know what to do. They'll keep the traffic on their sight side and go through the roundabout regardless of what space you provide. But these designs tend to be associated with rural, high-speed locations or where there are very few pedestrians, and they provide a lot more capacity for both cars and trucks. So some would say, oh, this is the desirable, this is the perfect design. But this is where the whole discussion of trade-offs arises. Do we want to, we can, but do we really want to? So the larger entry widths, the larger circulating widths, potentially higher cost, higher footprint. That's okay if this is Arizona and land is cheap and there aren't buildings or anything sensitive nearby. You can get higher circulating and entry speeds. And it requires a greater skill for the designer to be able to lay these out and get them slow enough so that if there are pedestrians crossing, that we don't see 30 miles per hour in the vicinity of crosswalks. Some designers have responded to this preference for the larger lane discipline approach, and they've put larger long tangents on entries, and it creates kind of a hockey stick look to an entry where it's hooked and there's a tight radius and then a flat tangent area. And some of these roundabouts have been observed with drivers and passenger cars slowing through the area just ahead of the crosswalk and then actually accelerating into the entry. Instead of coming up to the yield line and having the maximal speed control in this vicinity, the speed control is farther upstream, and it contributes to poor yield compliance. I don't have a statistic to support that, but I know some folks who have had rear-end crashes because they stopped and looked left as the driver behind them cleared the curve and accelerated into the back end of their vehicle. Nobody I know. Oh, OSOW. I'll stop for questions at that point because there's a lot of material on this truck module, and I'd like to hear some reactions as to what people are doing, what other designers are responding to these needs and interests. I mentioned that it's difficult to judge which case to use. Is it based on 5–10% trucks or the total volume of trucks in the traffic mix? And so no clear definitive guidelines have been developed. What I just showed you is published in the Wisconsin Roundabout Guide, which I helped to author, and we indicated a preference for Case 3 designs at the department's request. I'm not sure that that's improving safety overall. Wisconsin happens to have a slight increase in property damage crashes with conversions to roundabouts in multi-lane configurations, which is a little discouraging. Because the safety record for roundabouts overall, in the early years at least, showed a lot of promise for total crash reduction in the range of 40%. But these days, and I don't know if it's attributable to this design or education, but we seem to be getting higher incidence of multi-lane crashes, and maybe the size of circles and the speed of entering traffic owing to truck considerations is one of the reasons it's happening. So I'm curious to hear what others are finding.
So those who are joining us remotely, last time I tried unmuting everyone, we had some chatter. So just go ahead, if you've got questions or comments, just put them into the questions box, and I'll JV those over to Mark.
What's up?
Just while you're thinking about questions, this is a Case 2 design. So this is where it's a little deceiving. So the truck driver thinks they might be able to stay in lane entering, and they go around, and it gets really tight for the second vehicle to get side by side. And his right wheel was all the way. Let's pull back. His right wheel is just about at the curb. So that's probably in a W65 configuration. The wheels aren't all the way back, and he can't stay in lane. So the point about the Case 2 design is it may represent or present the driver with a false expectation about what's downstream of the entry. If there's lane discipline entering and there isn't circulating, are we sending the wrong message? What are you seeing to be most common in Alaska? I don't have enough inventory or knowledge of your roundabouts to know what your two-laners are looking like.
Has one right on.
We don't have any two-laners here in
back to back.
Fairbanks, to my knowledge. Any of those who are joining us from Anchorage can chime in on that?
I know there's two roundabouts back to back underneath an underpass. I think it's the Dowling exit off of the Seward, and they're both two-lane roundabouts. And if a truck driver was to go across, you would have to cross over and take over both of the lanes.
So Ethan concurs. Yeah, we only have single lanes right now in Fairbanks, which is what I thought. But I do know, again, so any of those who are, I know we've got a few people from Anchorage with us.
The thing about the Case 2 design is that what we try to do in this graphic, it shows it well, that there's still about 9 feet of space. Even if the rear wheels of the truck do overtrack, there's space for a car not to be squeezed into that. So if they do try to pass the truck, they're not going to get crushed. This design is a little more compact than that, and it does make it difficult for the car. You can see he's holding back because he can see that truck is probably going to swing a bit wide, and he waits. And otherwise, he's on the truck apron, and that's not a very comfortable thing to have happen, especially if you're on vacation in this part of Arizona, thinking that roundabouts are great, and then you get pushed off the roadway from a truck.
Ethan added that of the single lanes that we have here in the Fairbanks area, the North Pole roundabouts, they used a special double trailer design vehicle.
Okay.
And the designer actually went out and measured up the trailers and the turning angles, etc.
Good one. That's the truck making the U-turn.
Mark, I wonder if you can comment. I do know, or I'm familiar with the roundabout that is right in downtown Glens Falls, New York, and they actually have signs posted that don't allow right-hand turns for trucks. So if a truck wants to make a right-hand turn, he has to circle fully through the circulating roadway and then out.
Yes, I am. I'm just looking for that for the sign here. This one, trucks use apron. Must go around the roundabout. That's one way of doing it. I don't like that sign because it's not visual. Trucks use raised area, and this is the one that's for the right turn.
Yep, that's the sign I was thinking of.
It's counterintuitive, but if you get the right messaging on the approach, if the traffic information system sets up and you have enough visual to show that it's not good sight distance of the right-hand curve, the truck driver will figure it out pretty quickly. Okay. Well, if there's any other questions, we'll take them near the end. I want to cover just a little segment on oversize, overweight considerations, something that most highway agencies want to be able to accommodate permitted trucks with permitted loads, things like wind turbines and flatbeds that are longer, oversized. And some of these photos show typical tower sections. It's actually a custom vehicle that sets up with a very low clearance, and how they get through. You can see central island issues where the truck driver's in the grass. So that suggests maybe hard surfacing if this is a frequent enough vehicle. I'll just take you through some slides on how we've responded to this. Wisconsin's, again, probably one of the leaders in this regard, and they set up a routing map, based on permits to date. A few years ago, they set up an ABC routing map that showed, high probability of use, lower and almost no probability of use, and then tried to clear the way, both with bridge design, height and vertical clearance, as well as loading accommodation. And then those routes that were in the AB class where roundabouts might be located, a fleet of vehicles was identified that are probable and at times likely, if it's wind turbines and wind farms under construction, that these vehicles are likely. So the farm vehicle, pretty likely in rural Wisconsin, what's called the WB67 long, or has about an 80-foot trailer combination, and these are still on the road system, though they require permits. The mobile home, it's sometimes the wheelbase is shorter, but the width of the vehicle requires additional width, and it's the same of the farm combine as the overall width of the header is sometimes 20 or 24 feet if they don't take it off and put it on a trailer. Then moving into some of the tower sections for wind farm equipment, they're custom vehicles, a base section, a mid section, and then there's this DST lowboy, which is a common, oversized backhoes, dozers, manufacturing equipment. These are fairly common on the road network. So you see a variety of these different vehicles, and so an agency, Alaska DOT probably has to look at what's on the system, what's being permitted, how frequent is it, and develop a fleet diagram. And then there are, in AutoCAD and AutoTrack, depending on what modeling software you use, this fleet of vehicles is set up with templates in that design software so that the designer can test the swept path requirements of any one of the vehicles. Now, whether it's Georgia or Wisconsin or Alaska, the fleet might be slightly different, but the point is that it's organized and you're systematically looking at which is the vehicle that's likely, and it's not just necessarily the largest one all the time. Georgia, for instance, and I pick on them because their approach is going to be they're probably going to design for the lowboy, the 100-foot lowboy, mobile home, and the 67 long or WB92, and anything else is going to pay its way. That means that they're not going to provide accommodation for vehicles over that size that require permits. When they pay their way, that means they'll have to move signs, lift guide rail, flatten slopes, lift utility wires, deal with bridge clearance issues, and anything in between. I don't know if that sends a positive message to the freight industry, but the reality is there's a cost implication of doing this. The good news with roundabouts is that there isn't a sacrifice in the operational quality and safety of roundabouts to accommodate OSOW. At first, when we began to look at this a few years ago, we were concerned that roundabout entries would have to be extremely wide and circles made larger, and as it happens, that hasn't been the case, and I'll show some examples of where we've gone with this issue. The vertical design with that lowboy really reared its head here a few years ago. We had a couple of loads get snagged, and one was snagged on a truck apron for about 4 hours and stopped a lot of traffic. Immediately, the department responded with a bulletin which included the change in the cross section, and that was to put a crown in the circulatory roadway, whether it's midway or a third, 2/3. But they essentially flattened the slopes on truck aprons down to 1%, went with a 3-inch curb height, and then put a crown in the circulatory roadway. And that was to get the wheels up above so that the lowboy, the flatbed, wouldn't snag on the truck apron. Now, your conventional cross-section for a single lane is likely 2% off the truck apron, 2% off the traveled way, and when the wheels are down on the low point and they straddle and circulate, there's a very good chance that they're going to snag onto the truck apron, and that very thing happened in a compact 2-lane roundabout. So in response to that, some agencies are going with a more moderate approach so that this kind of thing doesn't happen. Very difficult to get these off if there aren't hydraulics. Once the truck is snagged, backing it up isn't easy, and they often go ahead with some force, so once they've stopped, it's very difficult to get them to back up. So the potential accommodations is that entries and exits would be made wider, but I think there's other ways to get around that, and that's using mountable and over-tracking areas on the outsides and in the circle, whether it's aprons or pavement behind the curb, and even crossovers of the median areas. Removable signs and sleeves is a common treatment. So the change in the circle shape and size won't affect the operating characteristics with speed control and capacity, sight distance, and so on, but it tends to result in some slightly different shapes for truck aprons. That happens to be the WB92, and the rear wheels, if not the vehicle hanging over, is going to need an outside truck blister, we call it, or an over-tracking area. The truck apron is going to have to shape differently because the vehicle coming from the other direction has a similar problem. The lowboy, this is where they tend to snag onto the truck aprons. I don't know if I have the video here. No. Backing up. So you can see they fit within the traveled way reasonably well with a truck blister on the one side, a slightly wider apron, and on the exit they're comfortable. This is a ramp treatment where the off-ramp was designed and looked at for several different configurations. One of them was the lowboy combination, another one was wind turbine, and a cutout of the splitter island on exit was developed with an over-tracking and mountable area. So it's kind of a 2-stage curb where the curb height at the edge of the travelway is maybe 2.5 inches, and then there's a full vertical face curve section of 6 inches in behind the swept path area. This was an OSOW accommodation in the first instance where they're only making through movements. And you can see this very large pavement area, the size of a standard truck, and how much bigger the oversized load would be coming through and meeting these areas. Widened aprons and widened areas on the right-hand side. So all of the important features of speed control are still preserved, but the overtracking areas are accommodated. Questions about that? Anyone? See if I can find, I'll show you a little video while you're thinking about a question. Rock trencher, 128 feet long on the lowboy. And this was staged. They knew this permit load was coming through, so they got the cherry bucket truck cherry picker in place. And you can see it has a Jeep section, so an intermediate section between the tractor and the trailer. Then the flatbed section, which you can imagine is maybe 6 inches of clearance. Some of these will have rear steerability if they're large enough. Not bad for a single lane roundabout. Not a very steady camera. Similar configured vehicle, tractor, the Jeep section, and then the lowboy. No questions? Okay, so that kind of caps off the users. If there are any users we missed, we can come back and talk about that afterwards. The next section I want to talk about is kind of a slightly different topic entirely, but I felt we should put something in because this comes up often enough in in the traffic engineer's toolbox. We have to know how to analyze and evaluate roundabouts in a system, and whether it's roundabouts as a system with closely spaced signals in proximity, or a system of closely spaced roundabouts, or a network of roundabouts. So spacing between roundabouts and traffic signals. The analyst should try to set the spacing, if it's possible, such that the 95th percentile Q from either direction can occupy the space in between without there being overlap. And you can imagine with this design, red light, Q backs up into the roundabout. Often this is the case where the signal Q backs into the roundabout and the roundabout Q is shorter, and rarely ever backs to the signal, because the capacity of the roundabout and the way it services demand it's sort of incremental and progressive, and it just tends to take on the traffic, and it can move up rate is good, and the queue is shorter. But there can be a spillover from signals. So how do we analyze that? So roundabouts and coordinated signal systems are somewhat incompatible. It's generally undesirable to have a roundabout located near a signalized intersection, but there are occasions when the corridor analysis may show a roundabout to be a reasonably good option. And that's where I find instances like that. It's usually where the signal control is on multiple legs, and say a 5-leg intersection in a coordinated signal network where the phasing is very difficult, and the green band is minimal if there's any green band at all. So it's, and the cycle lengths tend to be long, so the queues might be quite long, and the roundabout may deal better with the capacity issue of the multi-leg intersection, even in a signal-coordinated network. And anytime we see queues extending between adjacent intersections, or the possibility of that, we need to conduct further analysis. I'll pull a video up in a minute, but I want to just set this up to show you what's going on here. So this is the north end of Phoenix. An interchange pair of roundabouts was installed about 2001, and some modifications in 2005. During that time, from about the 5 years of 2004 to 2010, 2009, all of this infilling occurred from this town center development with large anchors of Walmart and some other shopping center uses. There's even a little roundabout in this one. There's theaters, restaurants. So there's a very large regional attraction to this area. Traffic signals at these two major roadways, 19th and the next one about a half a mile away. And I have to put my phone on Do Not Disturb. So what we're going to see is a little bit of video, and you can appreciate that drivers coming along through the signal coordinated network might get progression up to a point, and then when they reach the roundabout, they lose progression. Discharging from the roundabout, as random as roundabouts discharge, traffic would have to assemble into platoons and get back into coordination with these two signals providing, the setup for the downstream network. So it's this interface between the two systems that doesn't work so well. And let me show you an example of that. So now we're looking back towards that corridor, and there comes a platoon, and there's already some capacity constraints associated with this entry. That it possibly good bypass, free flow bypass accommodation, but there's enough off-ramp traffic that there's impedance of that Happy Valley Road entry at 2 lanes wide. Now the signal has stopped the traffic from upstream. The platoon is coming through. And just in that little time when I moved the camera to the right, a lot of traffic got through the roundabout. We turned away and about 10 cars went through. You'll see here comes the platoon again from upstream through the signals, and you've got some other side street action coming in between. And so there's kind of a steady approach, but there's still a plug of traffic every 60 or 90 seconds. Lots of left-turning traffic coming towards the roundabout. So this is going to exacerbate the queuing, and it'll back right up because the upstream signal's coming down as this one changes and the green comes in for the east-west direction. We see the queue starting to fill up. So this is one of the concerns that can develop, and we have a kind of a two-step analysis approach, a design step and a system-level review approach that I want to show you. We can come back to that video later. So loss of the progression, and then trying to develop progression on the departure side. So what we try to do is look at the roundabout and the signal as a system, and we begin the design of the roundabouts themselves, treating them as isolated intersections. So we develop the basic footprint of the roundabout based on the traffic demands, and then analyze it in 2 steps. So model the isolated intersection using models like Arcady, Rodel, Sidra, HCM. These are all deterministic models. You put in the values, someone else puts in the same values. 2 different people modeling will generally get the same answers. And then we model it as a system, more probabilistic models using simulation. 2 people have inputs. They sometimes get different answers. If you do enough model runs, you'll get some regression to the mean. But modeling them as a system highlights the problems that occur with interaction between the roundabouts and the signals, or 2 roundabouts if that be the case. And that's something that we want to evaluate. So any kind of system level review should have the design considerations of isolated and then the system level considerations in sort of a two-layer or two-step analysis approach. So programs like Pravix, and now even Synchro, which has the HCM equations for roundabouts built in. We've used Synchro with pedestrian actuated signals at roundabouts, and we're quite pleased with what it's showing us. It might need calibration, as all these models do, but there's the point of using this system-level review is not that we get the absolutely right answer. It just highlights potential issues. And with the knowledge of those issues potentially arising, whether it's lane choice, lane utilization, lane discipline, and lane continuity, we translate that back into the design of the roundabout to make it more robust. And so it becomes a bit iterative. Model it as isolated, evaluate it in the system, go back and make tweaks and modifications to the isolated roundabout again. So we compute the expected queues for each approach and design the entries to provide sufficient queuing between the roundabouts, or provide increased separation, or add extra entry lanes to reduce queues. And the idea is to minimize queues between roundabouts and signals. And another way, of course, is to limit the capacity of the inbound approaches. And I'll show you an example of that in a minute. And then the idea being you treat the 3 or 4 roundabouts in series as a system of valves, and you don't let any more traffic downstream than what the downstream roundabout can handle. And so you essentially meter or reduce the flow into the downstream system. And that's done iteratively. So you're trying to balance the number of lanes, lane use, and queues and lane continuity to achieve an optimal solution. Some examples where roundabouts have been placed close to signals, and you can see a quasi two-lane roundabout with single lane and two-lane entries, and how much capacity this roundabout can generate in relation to the lane requirements associated with the signal. If they only have about 25 seconds of green, they better make the best use of it, and the only way to do that is to multiply the number of lanes approaching. So very interesting contrast between the way capacity is provided. If it's only occurs every 90 seconds for 20 seconds of the 90 seconds, we have to provide additional lanes. This is every minute of every hour of the day, and even though there may be queues, the demand is serviced passively. And so there's no actuation, there's no so the only way we judge capacity is based on demands, and we apportion the capacity by numbers of lanes and somewhat geometry based as well. Other examples, well, this is the overhead view of the before condition. Let's see if I have any. So roundabouts, as a system of roundabouts, we've kind of led into that. There's been some really shining examples of combinations of roundabouts as a system, and looking at corridors like Golden, Colorado, where they replaced signals with roundabouts, it showed great improvement in travel times, slower speeds, but actually improved travel times, which suggests improved safety in the corridor because we can achieve ideal travel time without sacrificing speed, and improve access to businesses by virtue of some of these restricted and median control. It used to be a two-way left turn lane, 5-lane cross-section with indiscriminate access, and it was much better organized. Access to business improved, safety improved. It was really win-win all the way around for this corridor. And there have been a couple of examples like this, where a series of roundabouts proved to be very advantageous. This is Sedona. They have 11 roundabouts, and the 5 at the top of the system on SR 179 and SR 89 here in the east-west direction replace these 2 signal controlled, and you can see the queues on any given day, with an aerial photo, and the speeds through the intersection area. You can see the access and development. There's motorhomes, very popular tourist area of Sedona. In these land uses with curb cuts and having difficulty getting back out on the roadway, a hotel here with a switchback roadway on a steep grade, and in the after condition, this is what replaced it without a sacrifice of the development and even the development access. The roundabouts in a retrofit were an ideal situation as a series. When we pull up the video, some video to show what that looks like. So they're linked with a median between them, so the access was restricted to right in, right out, but the development has the U-turn option to go through and go to make what otherwise was a left turn on a 5-lane cross-section is a low-speed U-turn back around to the other direction. So it's a much safer corridor without sacrificing all the turning movements or the safety of the driveways. And the second roundabout in a series. So this doesn't really need to be looked at as a system of roundabouts. When you evaluate the isolated roundabout here and look at the queue development, it would only be necessary to ensure that 95% of the 95th percentile queue could be stored in the space between. And if it could not, then expansion of the capacity of this downstream entry would be required. But otherwise, we wouldn't normally do a simulation run on something like this. We typically do that with signals and roundabouts. Another example of a corridor, and you can see the benefits for Sedona: keeping roadways narrow, calm traffic, reduced speeds, uniform speeds, shortened crossings, beautified intersections. So a roundabout in a series can revolutionize the corridor, both for development and traffic operations. Maybe the poster child of roundabouts and corridors was one of the first in North America. It was the conversion of signalized intersections in the middle of Avon, Colorado, and the conversion of the stop-control ramp terminals, and then Highway 6 or Route 6, US 6, at the base of this. So the closely spaced roundabouts was where the real benefits were accrued, because these back-to-back lefts and the queuing that occurred between the signals was mitigated with the use of roundabouts. So system analysis and design, again, we started talking about the isolated roundabout design and using those models and then modeling it as a system. When they're very closely spaced, we have at times had to model roundabouts as a system using VISM or Paramex. And I'll give you an example of that. This is a section of US 41 up in the Green Bay area, where the C and D nodes are ramp terminals for diamond configuration, very tight diamond. The E and B locations are very closely spaced. These were signalized intersections, and the ramps were also signal controlled. And this diagram was prepared to look at different origin-destination patterns to understand the flows between the nodes and the ramps downstream. If you simply were to take the turning movement diagram, you wouldn't know the origin of that traffic that enters this lane. So it's vital that we understand where this traffic comes from. And there are different sources. This left turn volume could come from a through movement upstream, or it could come from left turns from the side street or the frontage roadway. The left turns from the ramp could end up down in the right-hand lane or in the left lane. It could make a left turn at the frontage road. So in doing simulation, you would run different OD matrices and load the model with the different OD patterns, and then test the lane continuity and lane configurations on the roundabouts. And again, the queuing might not be absolutely the right answer, but it's going to reveal any issues with inconsistencies between closely spaced intersections. So that's where it becomes helpful. And this is the series of roundabouts where this kind of analysis is necessary. So that the choice of lane configuration upstream provides lane continuity without lane change through the system, so the driver can get in the left lane on the first roundabout and continue through and stay in the left without a lane change. And occasionally you'll require an additional lane on one of the roundabouts. If the upstream roundabout pumps a lot of traffic downstream, we may have problems with queuing between the two. So I mentioned that looking at this more as a water valve system, where what you let through the first roundabouts is going to affect the downstream. And if you want to keep these compact, you can look at the valving and effectively impeding some of the approach flow, not excessively, but impeding it such that you don't require 3-lane entries downstream, as the combination of the ramp traffic and the frontage road traffic could contribute to a different lane configuration at the ramp terminals. And we want to keep ramps free and clear for the mainline system. So there's different ways to approach it, but it should be evaluated as a system. NCHRP 772 is a recently published document, and it's going to supplement the urban chapters of the HCM chapters 16 and 17 for the 2010 manual, and provides new performance measures for the evaluation and accounting for things like free flow speed, where roundabouts are in series, the influence area of the roundabout, approach, acceleration and departure, acceleration and delay, geometric delay, which roundabouts is kind of unique to intersections, the impeded delay, which we understand from acute stop delay at signals. And these measures are being built into the new chapter. We'll see them in a couple of years, but you can purchase or acquire 772 online from TRB. It also includes a flow chart for comparing the performance of corridors with roundabouts to corridors with traffic signals or stop control. Quite a handy document. I sat on the panel for the research, visited Washington, and we reviewed the reports and the researchers' findings and guided their approach to this. The one thing that I was hoping to see in the study, which is sometimes difficult to quantify, was the safety effects of uniform speed. When we see a corridor of signals, I'll go back to our diagram, when we see a corridor of signals and we have a green band, and even when we don't, we'll see kind of a hurry up and stop mentality develop among drivers. They just want to get through the system, and if they can't get the green, they'll accelerate on the amber. And so we see a kind of a speed profile that has a non-uniform speed. And if this was a development corridor like our Golden, Colorado, or even Avon for that matter, we're backing up here, back to Golden, we have conditions near access and development where drivers are trying to speed through on amber. What the roundabout does is smooth the speed profile. So when you see another downstream roundabout coming up ahead, you're not inclined to accelerate as though there's an amber and you have to get through it. You know that the roundabout has a very minimal queue. You're going to get through it. It's just a matter of a few seconds. So we tend to find the speed profile of corridors of roundabouts to be smoother and more uniform. To me, that translates into improved safety for access and development, because a uniform operating condition is a more predictable operating condition, and that tends to be a safer condition. So I think that was one thing that the research had a difficult time articulating, because it's hard to collect data on that, and they only had a half a dozen or so corridors with roundabouts where they could assess conditions like that. But just the same, I think it's a very useful piece of research, and this framework for comparing corridors is also quite helpful. So keep an eye out for that, and I think that will be very useful. So we've come up to the end of that last section, and we can take on questions on any part of it, Nathan, and we've got a few more minutes.
Yeah, sure thing. So floor is open. Again, use the question dialog box if you've got any, and we'll send those along. Mark, we've got one that says, could you? So this is from Paul. If you could elaborate a little further on slide 28. So the inaccessibility, or with reference to the inaccessibility of a two-lane roundabout.
Well, what we're seeing coming out of U.S. Access Board is the regulation or requirement. If it goes into law, then all two-lane roundabouts will require some form of red indication or traffic signal accommodation. Recent discussions between Federal Highways and Access Board representatives seem to be closing the gap on the interpretation of what accessibility means. Does it require a red indication? A few years ago, that would have been the simple answer. But there seems to be a movement towards saying, well, accommodation and accessibility doesn't have to always have traffic signal associated with it. It might have to have some control device to alert drivers and to get them to yield. But as they're finding with pedestrian safety at traffic signals, it doesn't guarantee the safe passage and often puts pedestrians at risk. So it may be that a device that's accessible might have a flashing beacon associated with it. So if we get into things like the rapid rectangular flashing beacon, Actually, I have a video of that. We have a minute. I'll see if I can get my RFB. This is out in Washington, and RFBs were installed on 4 approaches. They're actually, although the video doesn't seem to indicate, there's a transit shelter here, so they're frequently used. And it's a poor video, but you can see the one in the horizon, in the distance here, working.
So,
You're just talking about the one up.
yeah, that looked like where the headed cross will probably start to.
The difficulty with this device is its location proximate to the roundabout, how close it's located, whether it's in the conventional crosswalk location or if on the exit it should be displaced. I don't have this video handy, but I have another clip of video from the ground level where the pedestrians are not pushing the button, or if they are, they're just walking without looking at the traffic. And traffic comes from the roundabout and is dealing with the turning movements and other vehicles, and the driver just looks up and almost hits a pedestrian. So again, more devices doesn't necessarily improve the safety of pedestrians. This is, most of you haven't met me, so this is me in the video. It's low budget stuff, believe me. So we have to do this stuff on our own because we can't get volunteers. But that's the idea that we're trying to teach pedestrians. And in the case of visually impaired, that's a tough sell because, you know, they don't know when it's safe to cross. So a two-lane roundabout might have to be retrofitted in some cases. The point is that hundreds of roundabouts have been built, very few pedestrian involvement, crashes, and so we think that the safety is reasonably good for roundabouts and pedestrians. It's just the visually impaired question is a tough one to address without, you know, thinking we should add more devices. And you don't always know. You got to wait till they stop. It's not safe until they yield. The point is, it's an assertive pedestrian. You know, they're signaling to drivers. In Texas, they raise their hand and signal back to you, but it's not always pleasant. Some parts of the world, they just ignore the pedestrian. Although Texas can be courteous at times. I've been in places, even in this part of the world, in Green Bay, where they ignore the pedestrian, even when you have your hand raised. That's why I had to do the video and not someone else who happened to be with me. Other questions?
I had one.
We got one, Mark.
Do you think the red indication in a roundabout would really hamper the effectiveness for moving the traffic through? Because it would cause people to come to a complete stop?
You know, it's a question of priorities and context. I think it's appropriate in some cases that we do that we impede traffic for the sake of the pedestrians. When it's a context issue with a high enough volume of pedestrians, where pedestrian priority is important, I think it's a legitimate direction to go in. If the pedestrian volume is very low, you know, having a crossing accommodation in a high volume roundabout situation where, you know, the crossings are indiscriminate, and let's say it was a school and they were pushing the button every 30 seconds, you could, you know, conceivably impact the roundabout capacity and neutralize any benefit of roundabouts for capacity, because the crosswalk is constantly occupied. We ran into a situation like this in a study, at least, and I want to show you a little video clip here. This is some synchro, and it's in a signal-coordinated network. And there's a school here in the video that shows there's a pedestrian crosswalk for the school. And we determined that the pedestrian volume was so high during the peak times that we would have to use the signal to meter the pedestrian traffic, because if we left the crossing uncontrolled, pedestrians would be impeding the traffic, throughout the peak hour, or at least the half hour at school times. And that would impact the roadways sufficiently that the signal was actually used as a metering device. And that's not how we started the analysis. We didn't expect that as an outcome. The problem with this is that the background cycle is 120 seconds. And if we only give gaps for pedestrians about every 2 minutes, that might not be acceptable to pedestrians. There's an expectation when you push the button that you get to cross within 20, 30 seconds at the most. If you had to wait 90 seconds for the next, for the next gap, pedestrians might just start crossing. So it becomes kind of a policy issue as to whether or not that's a reasonable thing to do. So the answer is yes, in some cases it could impact capacity, providing a red indication. But in some cases you want that because you place a higher priority on pedestrians.
Mark, I'm not too familiar with the background and emergence of the Hawk signal, but
Okay.
kind of what's the justification for the having the two red lights, alternating red lights on top versus just a stacked yellow and red?
I'm not sitting in the committee. I don't know for certain. I guess the reasoning being, we understand flashing yellow, but that's not sufficient, for regulatory right-of-way. So we introduce the red. But if it goes to a solid red, and the red is there for the whole phase, then we don't provide any passage of traffic, when the pedestrian has cleared the crosswalk. So the idea of the flashing red says to the driver, it's, proceed only when it's safe, when the crossing's not occupied. So really, in essence, a brand new device, but relying on some of our conventional, flashing red and all red, solid red indications to tap into what drivers understand, their existing expectations for the use of red. So it's really to clear, and maybe you see this in the video. When I show the video of this Hawk signal, you might have seen it here. Let me pull that back up. When it went back into flashing mode, cars could proceed. So it didn't congest the roundabout completely when the pedestrians had cleared the crossing.
But I'm just thinking, presumably, you could have just one yellow and one red. The red would be steady when the cars are to stop, and then that single red would also then flash when they could proceed if it were clear, much like you have at a lot of, the rural four-way intersections that have, flashing yellow and flashing red.
Exactly, so, like just a standard flashing red ball.
Yeah.
I suspect that the human factors of it, this looks a bit more like a railway crossing to some folks, the wigwag style of signals at railways. And maybe the committee in their wisdom, thought that this would be an elevated, response is required. So they added the extra ball and alternate the two, 1 second apart. There's probably research, at least some of the pilot studies that were done on the Hawk back around 4 years ago, that should be in publication. And if you're interested I suspect there's, it's elevated awareness is what we're aiming for here.
Yeah, I'm sure there is. I just didn't know if you were apprised of that research or not. Well, it's looking pretty quiet on the question front, Art.
Okay. Friday we're going to do some public outreach. I hope that's a little more I want to get some dialogue going because it'll be a shorter topic if we don't, which some people might appreciate. But I think things I want to get out on the open in policy are, who represents agencies and what policies concerning roundabouts do they have? Public outreach, is it project level or is it area wide? What have they found to be successful? Do they strategize? I'll go through some of those things and some experience from a number of agencies. I hope to make that a bit of a dialogue on Friday. And then I think the following week we're talking about capacity and software. And I should try and get some demo copies of the software into people's hands. So I'll send an email to the Transport Research Laboratory from the UK, and people can download and initialize the Arcady model and start playing with it before we get together on Friday next week.
All right, well, thank you again, Mark. So I hope those who are with us today will join us back here on Friday. As a reminder, we're still working out a location to host the recordings of this webinar as well as the PDF, so we should have those up and online soon, and I'll send the links out to those who are attending. So with that, we'll wrap up for today, and hopefully see you back here, same time, same channel on Friday.
Thank you. Have a good afternoon.
All right, thanks, Mark.